Hey guys, Miss Moxley here for your Monday recording. Let me actually flip over and let's look at the agenda for you guys for this week. So after your recording, you have the Birth of a Star lesson and quiz. Tuesday, you have Life Cycle of Stars lesson and quiz. Wednesday, we'll meet for our live session, and then we have Life and Death of Stars. And then on Thursday, you have your Life of a Star lesson exam. Friday, you have Intro to the Sun lesson and quiz, and then you'll have your notebook check. So we're talking about a lot of processes as far as stars are concerned. So today, I just want to take a step back. Friday, you guys completed the Big Bang lesson, and I want to go over that with you guys. So your objectives from this lesson were to identify events in and following the Big Bang, and then coming up you're going to explain how stars are born, then you're going to describe how stars are classified, and then explain the life and death of different types of stars. So you won't complete all of these objectives in this lesson from today, but you will complete them in the lessons coming up, and you should be able to complete these objectives by yourself before taking that exam, which is on Thursday. So that Life of a Star lesson exam on Thursday. You should be able to complete all of those objectives by yourself before taking that exam on Thursday. All right, so talking about Big Bang. When we're talking about the Big Bang, what we're talking about is a theory or an idea. It's a theory that there was a giant explosion from before existence even was known, so even before time. So this is considered nothing. There was nothing available. This explosion formed the universe as we know it. It is said or thought that prior to the Big Bang, all matter and energy was compacted into an infinitely small point. So everything was compacted, all matter, all energy, so everything, all planets, stars, asteroids, comets, meteorites, everything was compacted in this small finite point. And when this explosion took place, all of this matter, all of this energy, it went flying and scattering throughout what we now know as the universe. So this explosion called it an expansion of all of this matter and energy. And scientists who study the Big Bang, or who study light years and who study the creation of the universe, are called cosmologists. So they study everything dealing with the universe itself. Now, I did mention light years. And when we're talking about items, other celestial bodies, other galaxies, things that are far, far away from us here on Earth, I'm talking about a measurement in terms of the speed of light. So I'm talking about light years. I'm talking about an astronomical unit, an astronomical measurement. And with this measurement, we've discovered that there is another galaxy far off called Andromeda. Okay, and it is really, really far from us, and we use light years to measure the distance. All right, so back to the Big Bang Theory. Once the Big Bang Theory came into effect, we had this explosion, we had this expansion, we had what is called universal forces that were created. And these universal forces that were created are considered to be invisible powers. Wouldn't it be cool for us to have things like invisible powers? But these invisible powers consist of things like gravity and, electromagnetic energy. All right. So from the Big Bang, we had our galaxies created, our planets. We had these universal powers. We have light years that were created. But let's put this into perspective for you guys. So in the lesson, there is a balloon activity. And you're not going to do the balloon activity in class, but if you want to go home and do the balloon activity, that's perfectly fine. But I want you guys to imagine a balloon. You've probably seen a balloon maybe at school in terms of a festival or an assembly or some sorts of a gathering, maybe a party, maybe a birthday party that you've had. So in terms of balloons, you know that you have to blow up a balloon, whether you blow it up by mouth or whether you blow it up using helium. But let's just say that with this balloon, we're going to take a couple of pieces of tape. So 4 or 5 pieces of tape, small pieces, and let's just randomly place this tape on our balloon that we've blown up a little bit. And we're going to spread them out a little bit. And let's say that we take a couple of little pieces of paper that we've wadded up, maybe something like the size that you would use once you've punched a hole in a piece of paper. So those little bitty pieces, those little hole punches, let's just take maybe a few of those and place them inside our blown up balloon. So just imagine we've got this blown up balloon, we've got a couple of pieces of tape on the outside, and we've got a couple of tiny little pieces of paper on the inside. Okay. As we continue to blow up this balloon, what we've got going on here is expansion of our balloon. And our balloon is representing the beginning of time. So the universe where all matter and energy was compacted into a small point. Okay. But as we begin to blow up our balloon, we've got this expansion that's taking place, and the distance between our pieces of tape on the outside of the balloon are going to increase. Okay. And maybe the little pieces of paper on the inside of the balloon are stuck due to these universal forces like gravity or static, are stuck to the inside of the balloon, and they're also expanding farther and farther apart. Now, as we continue to blow up our balloon and giving it more and more expansion, eventually our balloon is going to pop, and it's going to send pieces flying, okay? And it's also going to leave this, what's left, the shrapnel, the debris that's left, still stuck together. Just like our galaxy is in a spiral shape, you would have little pieces of what's left of the balloon. And this balloon is going to represent our galaxy, our universe as we know it, because it has expanded. We've had this explosion, and then we have pieces that are in their final resting place as far as the universe is currently concerned. So you can measure the distance from the pieces found that are scattered maybe all over the floor, or the pieces that are left on what's left of the balloon. You could measure those pieces and see just how far the Big Bang sent not only our planets, but the pieces as far as your balloon are concerned. Okay, so that activity is just sort of a visual to give you an idea as to what may have happened as far as creating the universe as we currently know it. All right, so for today, guys, be sure that you go back, complete Birth of a Star lesson and quiz. I'm not going to say that these are going to be difficult lessons, but they are going to be a little bit tedious in that there's a lot of information between the lessons that are coming up that may overlap and may build off of each other. So be sure that you're taking really good notes this week so that there's no confusion as far as these lessons are concerned, and then we'll meet for our live session on Wednesday. All right, guys, have a great rest of your day. If you have questions, don't hesitate to reach out to me through email, and I'll be glad to help you as best as I can. Have a great rest of your day.